Okay, so now in this video, we're going to be looking at the same Seuvat equations, but now we're going to be looking at when the particle is moving up and down in a vertical direction. So when you throw a ball up or throw a ball down, it's going to fall, right, due to gravity. So in this case, our acceleration is going to be a version of g. So g value is going to be 9.8. Now, as you can see, I've listed out when the g value is a positive value and when it's a negative value. So when you've got the ball and you're throwing it up, then the g will be negative. It's going to decelerate, right? It's going to slow it down. When you're throwing it up and it's going to come back down again, the g value we use for the acceleration is still negative 9.8. When I drop the ball from the top or I throw it downwards, then we're going to have to use a positive g value of 9.8. Okay, so that's when we use a negative g value and that's when we use a positive one. So just to be careful which one you use depending upon the question. So we have a stone which is thrown vertically upwards from a point which is 3 meters above the ground with a speed of 16. Find the time of flight of the stone. So for this kind of question, I would always like you guys to draw the situation just so you guys can visualize a bit more. So we have a stone. It's going to throw upwards from a distance of 3 meters above the ground. So this distance here is 3 meters with a speed of 16, and it's going to upwards and it's going to go down like this, end up here. The velocity at which is thrown initially here was 16 meters per second. So this will be the diagram that you guys need to be drawing. Next thing, we need to look at listing out the Seuvat one. So the method is the same. So Seuvat, then you want to list out what you know from the information given. So they want us to find the time of flight of the stone. So for this one, you just have to think, what is my displacement? Where do I start? Where do I finish? Well, I started here and I finished here, right? This is where I ended up. So the displacement is the distance between those two. If I take the initial velocity 16 as the positive direction, that's the general rule that you should guys be aware of. So 16 is going upwards, that's the positive direction. If I end up below that direction, right, it means that the distance or the displacement is actually going to be negative 3 meters. Okay, so in this case, it's not going to be positive; it's going to be a negative value. To be very aware of that. U initial velocity, well, that's 16. We don't know v. We're trying to find this t value. Now, this acceleration value, we know it's going to be a g value, right? It's going to be 9.8. We just have to determine whether it's positive or negative. You can see it, it's going up and then it's coming back down again, right? So in this kind of situation, it's going to be a negative g value like this. Once we've done this, now we can choose our equation to use. So we're going to have to use s is ut plus half at t squared. So we're going to get minus 3 is equal to 16t plus half times minus 9.8 t squared. We're going to have 4.9 t squared minus 16t minus 3 is 0. And you have to solve for t. You can use like the quadratic equation. And you should get a value of t is equal to 3.44 or negative 0.178. Once again, time can't be a negative answer, so it can't be this value here. So the time taken for the flight will be 3.44 seconds. B, the total distance traveled by the stone. So that means it's no longer displacement, the displacement is negative 3. The total distance will be the distance going up and then coming back down again, okay? So what we need to work out is this actually the height at which it goes here. So i.e. the greatest height above it reaches. Right, once again, what we need to do here is we need to write out our Seuvat values or things we do know for Seuvat. Right, initial velocity A is still 16. Now displacement, if it's the highest point here, right, let's call that SH, that's what we're trying to find. At this highest point, the velocity, the final velocity has to be equal to 0, right? If it's not 0, that means it's still traveling up or down, i.e. it's no longer the highest point. So what you have to remember is at highest points, the final velocity is always going to be 0. Acceleration, this is going starting from here, going upwards, it's going to be negative g, and we don't care about the time, we're just trying to find this h value. That means I can use the equation v squared is u squared plus 2as. So we're going to have 0 is equal to 16 squared plus 2 times minus 9.8 times h, and h we get a value of 13.1 meters. So that's the highest distance it travels above, okay? But then want the total distance traveled, so it's going to go up h, it's going to come back down h, and then go back down a further 3 meters. So it's going to be h plus an extra 3 meters, which will give us a total distance traveled of 29.2 meters like this. So for vertical, it's a bit more difficult than the horizontal one. Just make sure you draw the graph or draw the motion very clearly. Make sure you determine very clearly where your initial pulse point and the final point is, just to determine the correct displacement values. Okay, let's try another one. So a particle is projected vertically upwards with a speed of 24.5 meters per second. Find the total time for which it is 21 meters or more above its point of projection. So first things first, we always want to draw the motion. It's going to go up and then it's going to come back down again, like this. It's projected up with a speed of 24.5 meters per second. So that's going to be our initial velocity here. And they want us to find the time for which it is 21 meters or more above the point of projection. So let's just draw a random line here. Let's say this distance is 21 meters. So the time they want is this interval here when it's above 21. Okay, so this is light blue one. Right, once you've identified or done the drawing, let's write out our Suvat values, the values we do know. Right, U, initial one is 24.5. Now, we want to find out when it is a displacement of 21. So S is going to be 21 like this. A, because it's going up, right, it's going to be negative 9.8. And then we're trying to find the times of this one here. Once again, I can use the S is ut plus half at t squared. So 21 is equal to 24.5t plus half times minus 9.8 t squared. We get 4.9 t squared minus 24.5t plus 21 is equal to 0, which you can now work out or use the quadratic equation. T, you should get a value of 4.53 and you should get a value of 0.47. So you get two values of t. This makes sense, right? Because it tells us there's two times at which it is a displacement of 21 meters above the initial position. So this 0.47 is when it's initially when it initially goes to 21 meters on the way up. And this 4.3 is the time it takes to go up and then come back down to reach this position here. So this is going to be when the time is equal to 4.53. So if you want the total time between 21 meters above, what we have to do is just subtract one from the other. So 4.53 minus 0.47, which gives us a time of 4.06 seconds for it being 21 meters or more above the initial position. And let's try one final one. So a ball is thrown vertically downwards with speed 5 meters per second from the top of a tower block 46 meters above the ground. So let's draw this out. So we've got a tower block, we've got a ball, it's going to be thrown downwards at a speed of 46 meters. Oh, sorry, 5 meters, sorry, a second. The tower block itself, it's a distance of 46 meters high. Okay, so this is ball number A. Now we have another ball number B, is thrown vertically upwards from the ground with speed 18. So there's another ball here, B, and that's being thrown upwards this time with a speed of 8 meters per second. The balls collide, find the distance of the point where A and B collide from the point where A is thrown. So they're going to collide roughly here, right? Let's just draw something like this. B and A, so that's where they're going to collide. And they want the distance from when A is thrown, so they want this distance x like this. So we just need to draw out just to visualize a bit more easily. But same thing now, even though we have two different balls, we just have to write two different equations or two different Suvat equations for each one. So let's look at A, so for A, let's list out what we know for Suvat. Okay, so S is a displacement going downwards, right? So we labeled that as x earlier. U is the initial velocity, so 5. V we don't know. Acceleration is going downwards, right? So for downwards, it's going to be a positive g, for positive 9.8. And time we don't know, let's label that as t as well. For B, Suvat again, let's list out what we do know. Right, S is a displacement, right? So displacement is going to be this distance here. If the total height is 46 and x distance traveled by x, then S will be 46 minus x for B. U will be 18, V we don't know. Acceleration in this case is going to be negative g because it's going upwards, right? It's projected upwards, and time is also time. As you should notice now we've got this, we can create two different equations. So we're going to use the same equation, S is ut plus half at squared for each one. So for A, we're going to have x is equal to 5t plus half times 9.8 times t squared. So x is equal to 5t plus 4.9 t squared. For B, using the same equation, we're going to have S is now 46 minus x is equal to 18t plus half times GA is minus 9.8 now times t squared. So 46 minus x is equal to 18t minus 4.9 t squared. So one equation here, we have another equation here, and I can use simultaneous equations or substitution, and you should get a value that t is 2 seconds. Remember they wanted distance, right? So I can plug in 2 to either equation, this one or this one, and you should get a value of x is 39.6 meters. So that you can see clearly that listing out what we do know for each particle initially, and then that way you can visualize much more easily and use the correct equations to work out each question.